Okay, so one of the things we'd want to do is we would want to be able to look at a value and determine the number of significant figures based on the rules we just discussed. So if we look at a number that maybe is 1230.50 seconds, we would see that all of these values or all of these numbers are significant. Okay? Since every one of the non-zero values is significant, zeros in between two numbers are significant, and then zeros at the end of the decimal place are significant as well. So this has 1, 2, 3, 4, 5, 6 significant figures. Okay? If we were to look at something like 0.001230 grams, we would see that this is 4 significant figures. Now why is that? Well, we know that this 0 at the end of the decimal place is significant. These numbers, 1, 2, 3, are significant because they're non-zero numbers. But these 3 values are not significant because they're just placeholders. Okay? We could easily turn this value into scientific notation. 1, 2, 3. 1.230 times 10 to the negative third grams. And we lost those non-significant, insignificant zeros because they're not significant. They don't have an impact on this value. But this 0 is significant because it leads to more accuracy. We know this value to be, to that level of certainty. Okay. What about a number like this, 0.0010230 seconds? Okay, again, this 0 is significant. This 0 is significant between two values. These are non-zero numbers. Again, these are the non-significant values. So this has 1, 2, 3, 4, 5 significant figures. Okay. What about a value like 152,400 kilograms? Okay, how many of these values are significant? Now we know that these two zeros are placeholders. This just tells us that the 4's in the hundreds position, 2's in the thousands position, so on and so forth. As it stands right now, this value is a little bit ambiguous. We're not sure if this 0 could be significant or not. So you can either say that this is an ambiguous number or that this has 4 significant figures. Okay? To be sure to incorporate zeros that are significant for values larger than 1, say we wanted to show that this value has 5 significant figures. We're going to try to say that that 0 is significant, but that one is not. Okay, how would we go about do that? Well, we're just going to turn this value into scientific notation. So we could say that this is 1, 2, 3, 4, 4, 5, 1.524 times 10 to the negative, or excuse me, 10 to the positive 5 kilograms. Okay, if we wanted to show that both of those zeros are significant, we could say 1.52400 times 10 to the fifth kilograms, because all values in scientific notation are significant. Notation are significant figures. Okay. Now, something that we're going to run into quite a bit in chemistry involve calculations, calculating numbers with different numbers of significant figures, or just putting a calculation into our calculator. A calculator can sometimes give us lots of different, lots of numbers back. We're going to need to be able to correctly display the proper amount of significant figures for all calculations. Now, to do so, there are just two simple rules that we're going to need to follow. Okay, the first rule is for multiplication and division. Okay, anytime you do a multiplication or division calculation, the answer is going to need to be displayed with the least number of significant figures from your calculations. The least sig figs from the calculation. Okay. Now, so an example of this would be, let's say we're going to involve 2.3 centimeters times 10.0 centimeters. Okay. This would give us a value of 230 centimeters, because we're only certain with two numbers of significant figures here, we should only report this value to two significant figures, because that 0 is a placeholder. It would be a little bit more accurate to put this into scientific notation: 2.3 times 10 to the second centimeters, showing 2 sig figs. Okay. Now, the second rule is for addition and subtraction. Okay. For that, for those calculations, your answer is going to be displayed with the least number of decimal places. Okay, so let's add 2.3 centimeters to 4.75 centimeters. Okay, and actually those units are centimeters squared up there. I just saw that. Correct that. So what is this value? Okay, so we can just put this into our calculator, and our calculator would probably give us back 7.05 centimeters. Okay, but because 0.5 centimeters, but because we are not certain of the 100th place in here, we don't have a value here, this limits our degree of certainty, okay, or level of certainty for this value. So we're going to have to cut this value off to two significant figures. Right now 7.05 is listed with 3 significant figures. Now to do so, we're going to need to round. Okay, we need to cut that to 2 significant figures, so we're going to drop this 5, and in most chemistry courses you're going to use the general rule of 5 or greater round up, 4 or less round down or stays the same. So 7.05 centimeters becomes 7.1 centimeters with 2 sig